Great, awesome. All right, people are coming in. Thank you so much. It's exciting to see the room. Again, my name is Dmitry Vinnik, and today we'll talk about domain-driven testing, and hopefully, you know, we would, by the end of today, we would know what we're actually doing at work. So, first and foremost, I always like to establish the goals. As I've mentioned, and people mentioned in the audience, there are other great talks going on in parallel. So I'd like to make sure that we're clear with the goals I hope to achieve, and they match the goals that you have. So first and foremost, I will discuss the domain-driven design, which will set the fundamentals for the testing, that application of DDD in testing. Then I would discuss the domain-driven design in practice, and I will apply it to test pyramid. I always, when I introduce a new concept, and the domain-driven design might be new for some of you, when I introduce something new, I'd always like to integrate it with something we all know, and hopefully when it comes to test pyramid, we all know and used it at some point in our career. And last but not least, I like to talk to be practical and beneficial, so you can actually grab a tool or two, or maybe just the practice itself back to your workplace, and hopefully, you know, get a promotion out of it or something. So, where do we actually begin with this talk? And you don't have to go any further than the title of today's presentation. So let's actually dissect it a little bit. Subtitle is just for fancy reasons, so let's drop that part, and let's focus on domain-driven testing. And we have to begin with, again, the first part, domain-driven. And when we say domain-driven, it seems kind of incomplete, and you might be asking yourself, domain-driven what? And the answer is clear if you've been paying attention. It's going to be the design that we will focus on. But again, the design by itself, the term is not clear for all of us, so I always like to clarify and establish it as well. So design is usually good for a couple of things at least. It's good for patterns as a whole, and as we know, patterns basically are the best solution to common problems. And we'll come back to this point later on and why this can be tricky. And they also good for like abstractions, models, and like modules to abstract complexities away, so it's easier to, you know, develop for and test, which is important for today's presentation as well. So with all these kind of three principles I've mentioned, you might be asking yourself, so what's the problem there? Is there even a problem in the first place? And I would say yes, there is a problem with this approach to just follow the design by itself. And there are common design pitfalls or issues that you might be encountering while you exercising the design practices that you might be read about back in you know, college or university days. So, first and foremost, the principle people usually follow while it comes to the design is this idea of one size fits all. Again, you might have read Gamma design patterns or any other books or just some blog from a random person, and you've been exercising the same pattern for all use cases. Instead of fitting your, you know, finding the solution for your problem, you're trying to fit the problem into the solution, into the pattern that you already know of. So this is a common anti-pattern you should avoid. The dogmatism, the idea that you're trying to follow the advice, or in this scenario, a pattern, by every letter in the book, where you've read it and you're not making it flexible. You follow every single rule in the textbook, and instead of being flexible and adjusting it to your particular use case. As a result, there is no real design evolution, and really leads towards this design stagnation. You're creating a legacy system from the get-go. You're not, again, building the software for your use case. You're not attending to the business need. You're just attending to your desire to meet dogmas and follow best practices, as they've been called in the internet. So, how do we tackle this problem? Domain-driven design, of course. Otherwise, I won't be even talking about that. So, when it comes to these pitfalls I've highlighted, those 4 pitfalls of the design, when it comes to domain-driven design itself and how we're trying to tackle them, would go one by one. So, the one-size-fits-all issue. We will tackle it by the common principle in DDD. By the way, I will be using DDD as the short version for domain-driven design. So the first principle we'll talk about, context matters. The domain you're working in is essential, and it's important to know and dog food on that domain. For instance, if you're working in the company or software that builds websites, you shouldn't be just focusing on your software product. try Wix, try Squarespace, try WordPress, try more software products in the domain, in the area you're in. It will help you to test, to develop, and to argue about features. Don't just listen to the user experience researchers that say it has to be done that way. You can always argue, oh, you know, Squarespace does it this way and it works very well for them. So really know your context. Dogmatism with domain-driven design we would tackle by providing design guidance. Just a set of not solid rules, but a set of outline and guidance that you can just follow or adjust depending on your use case. And of course, this one is fairly simple. No, you just drop no, and hopefully I'll show you how to reach the design evolution when it comes to domain-driven design. And last but not least, this concept of design stagnation would tackle by discussing design lifetime. This is something very personal to me, and I'll explain why, because this is the painful point that probably all of us have encountered at some point. So let's begin by discussing the context matters a little bit closer. So when it comes to the context in domain-driven design and our work in the first place, the major concept of DDD is a ubiquitous language. And this point would be important throughout today's presentation. The ubiquitous language, what it basically means is that you're trying to talk the same language while you discuss your particular domain. If I'm calling my users of my application customers, I need to make sure that my project manager doesn't call them accounts. We need to make sure that we call them the same name, customer, whether it comes to how we call our Java classes, our tests, our documentation, or even during the meeting. The reason why it's so important, even though it might seem so small, you know, customer and accounts, while you're in a meeting and someone, you know, gives you a presentation and they mention our account numbers are growing, and someone raises a hand and saying, you meant customers, right? People have to stop their thinking for a second and think back about the very definition of the thing they're talking about. It seems simple, but that waste of time would hit you in the future. The bound context, which we'll also discuss in a few minutes, because that one needs a better clarification. And domain segregation. Not everything is as important as you think it is. If you are working on some startup that's main focus is mobile first, in that case, if you know that your business actually is focused on mobile, you might not need to focus your development and test effort on the desktop application. While knowing where your the main revenue and main focus is, you know what to focus on. And again, in the scenario I showed you and highlighted mobile versus desktop, you would focus on mobile if you know majority of your customers are mobile first. So again, let's discuss ubiquitous language a little bit more and what I mean by that. The main point, especially in Europe, where I've noticed that segregation of different roles is still important, you need to make sure that engineers and testers have a very direct line of communication. If you as a leader, you see any blockers in between, you need to make sure that you do your best to break those blockages. You need to make sure that the pathway is as clear as it gets. At the same time, you need to make sure that you set expectations right, so the testers or engineers both follow the same rules. When they go and ask a question, it's not just a question for the sake of a question. They've done their research. If anyone ever tells you just Google it, hopefully they've been nice and they don't just be passive aggressive. And if they've been saying you over and over, this is a Googleable question, it means you haven't done your research. Do some searching online before you ask a question. Because again, you want to build that credibility, but this most important, you shouldn't feel threatened or not empowered enough to ask a question. So make sure you have that communication going from the get-go. But again, some people forget, it's not just these two roles in the team. There are also the main experts, other stakeholders in your team, whether it's product owners, managers, or your end customers, those who actually use your product and interact with it the most, are the domain experts. And you need to make sure you talk to them as well. Don't just sit in your silo, in your box as a tester, as an engineer, and just forget about all other pieces of your software. Again, it's the business that dictates the need of your product. You're not doing it for the sake of your ego. So you really need to be customer-oriented. User-centric is what's important. So what is the conclusion here? The conclusion is fairly simple and very obvious, though, is that the communication is essential. And not just in domain-driven design, in life as well, as we all know. But when it comes to the bound context, it's a little bit different than what I've just talked about. But it's still connected. So when it comes to the bound context, there are a couple of level of boundaries that we need to establish and make sure that we have expectations within the team. First and foremost, it's the linguistic boundary. The example I gave about how you call your end users, it's how you use language to communicate. But it also goes down to how you write code and how you name your classes. I've seen over and over again where developer would call customer.java their end users, and the testers will call it something like persona.java. It might sound so simple, but in reality, again, when you get a new hire, you have to show them that when I interact with a test object called persona, I actually mean customer in production. You don't want to have that communication. New hires have enough to worry about than your linguistic hell that you've put yourself into. Logical boundaries is the next level. When it comes to, for example, the architecture principles of layered architecture, where the application might be even monolithic for that matter and exist in a single, let's say we use Java, in a single JVM on a single machine, but in reality, the code-wise and modularization and abstraction-wise, it will be abstracted into the app and business and infrastructure layers. So while they exist on the same physical location, the logically will be separated. And that's what you need to go towards, that logical boundary is in place. And last but not least is, again, next level of physical boundaries, which has been very popular with this abundance of microservices architectures, where parts of your application can run in completely different instances, different machines. So you take it to the next level. And with boundaries, your testing and your development changes drastically, because you can, again, focus on that unit of work, test only that unit of work, develop, debug, and enhance just that unit of work. So by building these boundaries step by step, you can enhance your software application regardless of what stage you're in. If you're still a monolith, you would just focus on a linguistic boundary and logical boundary. If you're going towards more microservice and hexagonal architecture, maybe you can put physical boundary in place. And there is an argument for that as well. And again, domain segregation, last but not least point here, is that not everything in your application is as important. There's been a common problem where I've read the book it's called Own Your Day by Aubrey Marcus, where he talked about him starting his own company. It was like a fitness supplement company. But regardless of what sort of company he talked about the problem where they had 100 customers, and those customers are awesome, but there was one customer who they spent majority of their time, effort, and emotional concern would come from, because the customer would always be needy, asking for those extra support questions. But after they analyzed how much time they spent on that one customer versus 99 customers, they realized that that last one doesn't worth it. The money they paid doesn't worth the amount of time they spent. So after doing some analysis of their case supplement product, they figured, let's drop that one and focus on improving 99 other customers' support. The same comes to software. Know what you focus on. As I mentioned, the startup situation, mobile versus desktop, know what your business is about. But back to the domain-driven design in the first place. We've talked about the context. Let's talk about the design guidance that I'd like to highlight today. And when it comes to the design, there is another important point of context mapping. That's important to us. The minimalism is just a good practice to follow, and I'll highlight a couple of principles that we all know and love, I hope. And last but not least, particular design principle that I like to follow, design by contract. That will help you, again, to improve your quality of software on development and the testing level. So, context mapping. There is a great example I like from Martin Fowler blog, where it's a great situation to discuss here. So this is basically what's called a context map, where you can see that depending on what context you're in, and again, it's going back to the domain segregation. If you're working in the sales department, or as they call it, sales context, it would be different how you view customer and product, in comparison to, let's say, support department, support context. To give you more better illustration, if it comes to how you define the Java model for customer in the sales department, you would focus on things like number of calls that been made to this person, their credit score, and stuff like that, very sales oriented. But when you're writing customer.java or customer abstraction for the support context, it would be completely different information you worry about. It would be what severity of cases they've created in the past months, what is the contact person for escalated issues. So it would be different abstractions altogether. And if it's in more practical terms, people usually handle this by having a single table in database, and they just use the different views for different contexts to represent the data. So that's basically the idea, that you need to know what department you're in, what context you're in, and you might view different models. While they might have the same name, you can view them, interact with them with a different perspective in mind. So it acts as documentation, this context map. Some people print it out in their office space and they put it on the whiteboard. So if they discuss something, they discuss it next to the map of their product. And again, it's all about the communication. This idea of communication is essential for domain-driven design. And again, it comes back to us, even to the mapping point. But there is an important point to highlight. It's very challenging with any sort of documentation to maintain the current state of your knowledge share. If you've written documentation last month, it's very likely it got outdated in a week or even a day. So how does the context mapping tackling this problem of keeping it current? Something called galactic modeling language. It sounds very fancy and significant. In reality, it's extremely simple. I believe it's Ken Beck came up with that. I encourage you to look it up a bit more. But the idea is that it's all about just drawing boxes, lines, and labels. It's something basically that you can draw on a napkin. I believe it was created by drawing a diagram in a napkin. So the reason why I'm saying that is this is a great example of galactic modeling language in practice. The reason why I highlight it again is because to contradict and compare it to UMLs. Who the hell uses UML these days? And as I've been trying to tell you, it's all about the communication between engineers, testers, and domain experts. If you bring your UML to the tester or to the domain expert or vice versa, and one of those people don't know UMLs, you would waste your time discussing not the product, but what does this dash line means, right? You don't want to explain aggregation and such and all those concepts to someone, right? I only ever use UMLs in university and academia, but never actually in practice without having that extra discussion of what this line actually means. So to avoid that, focus on the reason at hand to communicate, to document, and keep it current. So that's the context mapping. Minimalism, it's just a good point in general. I'm not going to say about life, but when it comes to software, because fewer moving pieces result in fewer things to test, and ultimately because fewer things can go wrong, right? The solid patterns basically keep it simple, remove as many dependencies as you can. All those simplest things is what you need to go for. I especially like the Yagni, basically. You're not going to need it in the future. As a developers, especially, I hope we all love what we do. We like to implement a new extra feature, something very complex. But if it's not useful, delete it. Don't be attached to that code that you've written. And I come back to this attachment point later on. Last but not least is the design by contract. So, design by contract, something I really love to talk about. It's a very simple concept. It's basically, you think of your code the same way you would think of how you communicate and work with people. I would hope many of us have an employment contract of some sort, right? And in an employment contract, we have a couple of things defined. And those things would be your rights to get paid, to the very least, and your responsibility, do the work. The same way we need to be writing our APIs, or whatever you write for that matter. But ultimately, it all comes down to the API. It's basically, when you write the API, you have responsibility of some sort that you define in your documentation, or even in the name of the API. And you have responsibility. And you have the right to a certain scenario that API is invoked in, to certain arguments, And you're trying to follow that contract that you sign by creating and publishing the API. And to give you an example, let's take an example in Java. The very fact that this simple operation has a return type integer, it means I have a responsibility to return the integer. And the fact that I have integers as arguments, that's my right. I have the right for integer input. That's fairly simple, right? If I go further, I can establish my right even more as a developer. I say the input should not be nullable. It's one thing to write Java doc saying it shouldn't be nullable. It's another thing to actually enforce it with precondition and just fail it fast, which I like to do the most. You can even do annotations, which is nothing more than the suggestion, or you can improve it with some extra tooling. Operation doesn't concern us in this scenario. What's important is the last part, where we're trying to, again, establish our responsibility that we've promised with even the name of this API, that we sum to integers and it always will produce positive value. And this is what we're trying to validate by the end. So we promised, we delivered. It's not going to be nullable. It's not going to be null or negative ever. Actually, it can be null. It can be zero. Don't listen to me. So that's fine, but the design evolution is not any less important. And when it comes to design evolution, there are two major principles I like to follow. The first is the supple design, or in other words, flexible design. You should be ready for a change, and I'll discuss that in a minute. And that second part is coming back to the communication point. You need to be making strategic decisions throughout your development and testing. So, when I talk about supple design, I always like to highlight a few simple principles. First and foremost, keep your operations immutable wherever you can. It comes back to the same point of minimalism. Fewer moving pieces in case of immutability, fewer states to manage. If you send out a mutable object to the method of some sort, you are confident it won't change. You don't have to keep testing it over and over. So that's important for us. Declarative design. If you follow, Java evolution or many other languages and tools lately, they all moving towards declarative design, where you focused on what you want to achieve instead of how you want to achieve it. Simplest example there is, you are trying to search for something and you want to have a binary search in place. You don't care how binary search is implemented. So you don't care about how it's done. So you use some library or use Java itself, something collections.binary search or whatever it is. So you abstract it and let someone else to handle hows. You focus on what, and your what is find an element in a collection. So you focus on the operation, on the problem you're trying to solve. You don't care how it's done. So that's what declarative design is about. And last but not least are domain-specific languages. And when I talk about domain-specific languages, it's about building something for your particular domain. If you're working in shipping, it might make sense for you to create the special abstractions instead of writing your Java classes. Instead, you're writing a specific language that you can show your domain expert and they would easily understand it. It's all about improving readability and improving that communication, creating the ubiquitous language. Even CSS, if you think of it, it's a domain-specific language. It's the way to communicate about style in a certain way that everyone understands, especially designers and product owners. And you can discuss the principles at hand, style. That's what CSS is about, right? To the simplest terms. And again, it's a ubiquitous language. It's being applied to the domain it's working in. So, it's a supple design, but strategic decisions are not any less important. And the things here, it again comes back to the communication. It's about the team collaborations. This is where I always like to bring up the, people with test expertise, testers or whatever, system you're working in. Basically, their job and any job of anyone in the team is during things like release planning. I've often seen a situation where a developer comes in after they prototyped something and they said, this feature would take me, if you work in an agile, this story would take me 2 story points to complete. But then the tester, this is where collaboration is important, tester raises their hand and say, it actually would take at least 3 points to test it. That's important because in combination of those 2 and 3, it would come up with 5 points, which changes your release plan drastically. This is where you really need to be absorbing the feedback, and this is where test expertise is essential, whether you are an engineer or you are a tester that's dedicated to testing the product. This is where the team has to get together and discuss the work that they are planning to, focus on next release or next sprint or whatever it is. And last but not least is an experience diversity. I always like to bring junior engineers in the team, not just senior or principal level engineers, or people from other backgrounds. I've happened to work with so many people, surprisingly, who used to be QA on nuclear submarines. And they have a different level of testing perspective than someone who's working on a sales software, because you don't want to mess up on a nuclear submarine. You haven't tested that, rocket. So it's very interesting to bring those people together and hear from them when it comes to the release discussion or sprint or feature discussion. And last but not least, the design lifetime. When it comes to design lifetime, you're trying to establish the expiration date of your pattern. Software in IT world is changing so drastically within just a couple years, so you have to keep up. So some people, when they write software, they actually say, make sure you review it in a year or so. If you go beyond 5 years, it never works out. In 5 years, things will change so drastically. So you say, review it in a month or review it in a year, but you're still trying to be realistic. But to give you a good illustration of how world changes, if you were to learn about domain-driven design, you probably would pick up this awesome book by Eric Evans on domain-driven design. It was published in 2003. So quite a long time ago, I would say. And in this book, while discussing domain-driven design principles, Eric Evans primarily talks about layered architecture. But 10 years later, what we see is this great book, another one, Implementing Domain-Driven Design by Van Vernon. And here, just 10 years later, he talks about completely different architecture styles, like hexagonal. He talks about service-oriented, how to apply microservices. And it's not because, Eric didn't know about those, levels and ways to architect and develop an application. It's because things changed. Principles don't change as much, they evolve. But again, the architecture type has changed so drastically, and you have to keep up. You have to set expiration date on the software you implement. And what I always want to talk about when it comes to this point is the emotional attachment to software. I've worked with people in the teams where they've developed a product and they have such a hard time giving up that product or giving in to the fact that it has to be completely rewritten or even thrown away. Should be ready to, as Stephen King says, kill your darlings. When it comes to even preparing the slides, you have to remove some slides, even if you love them so much. So it's important not to get emotionally attached to software. So, domain-driven design and all, so great, right? All those 4 principles. But let's step back a little. We've talked about the domain-driven part of the talk. Let's now discuss the testing application of domain-driven design. And if I talk about domain-driven testing as a design principle, have to again come back to the DDD, those 3 major points of domain-driven design: the context mapping, the bound context, and ubiquitous language. So when it comes to domain-driven testing, the context mapping becomes nothing more than the test plan. And I will show you that in a second. So the context map, it becomes a test plan now. Looking back at this map as a tester or even an engineer, I can figure out where my focus of tests should be. If I'm in a sales context and I know that I care about number of calls made to this customer, their the credit score, I would write my tests for those fields only. I would only write my tests for those scenarios. I wouldn't be testing ticketing system of support department. So I would write my test plan with that in mind. When it comes to the bound context, it becomes the test structure. With tests in general, beyond the unit tests, the problem I've seen is you have to draw very solid line between production entities and test entities. And what I mean by that is I've seen people try to jump between the modules. Unit test modules, and what people do is they just import production entities into the test infrastructure, try to access the fields directly in the production classes, and test those. I understand doing that for the unit tests, but when it comes to integration and end-to-end tests, where you're trying to be more like a customer, that's just defeating the purpose. What I like to do is create test abstraction, so test customer.java or something, that's instead of test customer, just reach out to the name field of production entity, what I do is there would be a method called getName, and behind the scene, that test wrapper, I would invoke a web service or some API that's actually used by the end user, by the end customer on the real application. So indirectly, I'm able to utilize and test those fields instead of hijacking and just breaking the single responsibility principle. So you're trying to make sure that you have the structure very clearly separated from one another. And the ubiquitous language, again, it comes back to how you write your cases. As I've mentioned with that, naming of the test classes and production classes should be matching to some extent. Otherwise, you're going to speak about the same concept in different language, and you want to avoid that. So that's quite theoretic so far. Let's be more practical, I would say. And again, as I've mentioned, I always like to combine things we all know with something new, like domain-driven design. And if I were to ask people in general how do they usually test, is by following the test pyramid, right? You would have the unit tests in the lowest level, which would match simple three concept of being lowest cost, highest speed, but they give you the lowest confidence level in your application, the lowest fidelity. The integration tests take you to the next level, and end-to-end tests usually are the costliest in terms of maintenance. They are the slowest, but they give you the highest confidence because they are utilizing your application as if it was a customer, right? So that's a test pyramid. But again, we're talking about domain-driven design. So let's put a spin on test pyramid from the domain-driven design perspective. So let's change it a little bit. Now, it would look something like this. And if I talk about domain-driven design test pyramid, in the first level, we would have the main enforcing unit tests, which again follow the same practice of low cost, high speed, but low fidelity. The next step will be component approval tests, and last but not least are end-to-end task tests, which again follow the same three major principles of end-to-end tests. All right, let's begin by discussing the very first level though, the main enforcing unit tests. So, the main enforcing unit tests. First and foremost, when you're writing your tests, the good way to look at them is to approach them as an auditor. So you audit your software, real life application, how it functions. One way I like to write my code is so-called last day style. You're basically writing your code as if it was your last day at a job. You can approach it from two perspectives. One perspective is you're writing your code as if you don't care anymore because you're going to be gone tomorrow. It's not what I'm encouraging you to do. I'm encouraging you to look at it as from a perspective of love, because you love your craft, you love your software, right? To some extent at least. Is that after you leave tomorrow, someone who comes back and look at your code feels that they don't have to rewrite it. They can actually understand what you've done, whether it's your tests, whether it's your production code. You have to be writing code that the code itself is a design and design is code. That simple principle that you're trying to adhere to. And in practice, it's something called invariant approval testing that I'll show an example of. But the thing is, I've mentioned approval testing twice when I talked about components approval testing and now invariance, right? So approval testing is a bit different from regular assertion tests. And it's all about evolving validation. It's basically you take a snippet of your live application, of the real application that you're running in production, and you try to compare it. And it's the requirements and the real requirements, not the ones defined by project managers, but the ones that the customer is faced with, is what's evolving the validation that you do. Again, it's all about requirements-driven testing. If you had a bug in your application out there in production for 10 years, that bug is not a bug anymore. It's a part of the behavior the customer is used to. You might have fixed it in a month or so, but then the customer is like, oh, I built my entire application based on that behavior. So that behavior is part of the real requirements, but which might differ from what you assumed the customer should be using. It gives you higher fidelity comparing to the assertion tests, but it's a bit higher cost maintenance-wise and speed-wise because it requires you to have a snapshot of live application. But back to the domain enforcing unit tests, and in particular invariance approval tests. To give you an example, there are two main styles I've seen in the wild: property-based testing and the schema-based testing. So property-based testing, the example I'll give today would be on Quick Theory. It's a great library in Java. And the schema-based testing, people usually use a JSON schema protocol. Basically, define a metadata of your JSON, like, you know, there is a field should be a string, there is an integer field, integer should not be negative. So you're basically testing that metadata of the JSON format you're working with, which is fairly simple. It's an open source and it's a well-documented flow. But the Quick Theory is something I like to use myself. And I give you an example. So the reason why it's called Quick Theory is because you're setting up the theory that your software works in a certain way. So you make an assumption that we all like to do, right? You make an assumption and you want to quickly test it. So first thing, you define the Quick Theory instance. Then you say, in this example, we are trying to theorize that if I take any positive integer and I combine the two, it would always produce a positive integer. For example, they're trying to estimate how much time I spent watching Netflix or something. And they say, oh, definitely it's going to be just an integer. It's not going to be, you know, too big of a number. And I basically try to check it. Simple as that. And the result would be, unfortunately, a failure. And it will be it will show you right away that the choice that you've made was bad. You should not be using integers. You should be using maybe float or long. Because again, you get the overflow error really quickly, and it has a very expressive explanations. And it can go beyond primitives like integers, strings. You can go beyond that. Very nice framework, love it. And it's available for different languages as well. So, but going to the next level, it's a bit more engaging. And component approval testing, the first would be text-based testing. If you're working with log lines, for example, you're a company like Splunk, where you're trying to make sure the format of the log line matches a certain date format, a certain name of the thread you're trying to track. You can't just assert the value there in the date format because the value would change, right? Second later, it's a different value. But the format is what you're trying to check for, and it's going to be text-based testing. Snapshot testing is the next level. Very important for virtual DOM, like if you use React, for example, where you create a snapshot of a virtual component, you save it, and you compare it to later on. Great for legacy systems, by the way. If you have a legacy system you have to maintain, you create a bunch of tests, bunch of snapshots, and you're making sure that virtual DOM doesn't change. And a visual testing, which has been quite popular these days. But let me give you an example of text-based testing. It's a great software framework, test framework called Test. Personally, I don't like when people put test in the name of test framework. It's kind of an overkill, but regardless, it's a great test framework to use. Snapshot testing, Jest, of course, is probably the most popular and easier to get started with. It's an open source framework from Facebook, I believe. And the visual testing is something I would show. Obviously, Apply tools is one of them commonly used and explained and shown. I'm not going to show that. I will tell you about BackstopJS. Great, easy to get started, configuration-based visual test framework. So let me give you an example. Imagine I have the application. What I've written, when I go to America, I show them the American flag and I say, hello, that's all great. But it's a responsive app, so you probably can see very well here, but it's mobile phone. A mobile phone, it removes the flag and just has two fields. But let's say it's the location-driven, location-aware application. So I go to Canada, where I currently reside, and the flag changes, you know, the label changes. And if I were to write a regular Selenium tests, which are making sure that the flag shows up, I just have a selector for the flag, for the label, those would continue passing. But visually, you can see that things change quite a bit between America and Canada. So this is where visual tests are so important. Because if I were to write the tests, I can get started very easily. I can define the platform I want to test for, you know, tablet and the phone. I would say with this width and height is quite a tablet. So then I set up scenario. Very simple. I say load a certain URL, name a test a certain way, and find me particular selector. And I also can define the threshold, the failure threshold that I'm fine with, right? And if I were to run the test, it would give me, in this scenario, I actually have 3 different scenarios. I compare my previous snapshot of American flag to the current test at hand, and I see that the difference is huge, right? It fails right away. For my mobile, it also compares, and you can see the label has changed drastically. And if I were to just write my test for the flag itself, it would be also quite a difference. So BackstopJS is very easy to get started, especially as a proof of concept. I always recommend that to the teams that don't use visual testing yet. So that's the component approval test. But when it comes to end-to-end tests, I really distinguish them from regular end-to-end tests in the first place. So while they match the same principle of costs, speed, and fidelity, the important part is that you're really trying to make them user-centric tests. What I mean by that, instead of focusing on interactions, you focus on the tasks at hand. Code-wise, test-wise, instead of using so-called page object models, you use something that they call screenplay pattern. To give you an example, and I'll show you the code in a second, if you write in the login form tests, right? If I were to discuss it in the sense of interactions, I would write my code and I would explain it to the developer or domain experts, such as user clicks, username field, types, username. Next step would be something like password field, press, send keys, password. And it's very kind of cryptic and it's very interaction oriented. Instead, I want to abstract that and I create some abstraction called login form. And you say login form.accepts username and password. And those interactions are abstracted away. So you can just show that simple test that accepts username and password to an engineer, to the domain expert, and they can understand what you're doing without you implementing the behavior-driven development unnecessarily. So that's the idea at hand. You're trying to go towards tasks, user perspective. So the conclusion here is that you really need to be aware of user dimensions you're in, though. An example, if you are web user-oriented, so you are UI first, you are going to be writing your test for the client side. On the client side, I'm a big proponent that if that's your focus, your test should be in JavaScript as well. If you're API first company, so your API users oriented, you're going to be writing your tests on the server side as well. When it comes to the web users, I always recommend Protractor if it's Angular app, because it's really great for task-oriented testing. And server side, rest assured, if you write in REST services, is also great. An example of what I've mentioned with task-oriented tests, though, login form, you make an abstraction, you initialize your tests, you use Gherkin style of, say, given, and you explain it in a, user-readable, business-readable way, saying customer enters a username, you accept the username. Do the same for the submit button, so you just go ahead and submit. And of course, this test would fail because it should be failing without the password. So here it's a good example of how you use Protractor and making focus on not interactions, because you can see I don't have any send keys in here. I focus on the task at hand. So that's all great. We talked about that, but how do we, after implementing all of that, how do we actually find flaws in our tests, in our domain-driven design in the first place? Because that's important. I always say experiment, and the best experiments are done by utilizing so-called domain breakers. Domain breakers, you probably heard of some of them. The first I always like to highlight are outsiders. The first thing you would ever do to an intern and a new hire is that you put them in front of your application and you tell them, try to do something. Don't show them the code. You might not even mention what your software does yet, which would be interesting how you hired them in the first place without them knowing what the product is. But anyways, you sit them in front of the application and you tell them, just play with it for a bit. They might uncover some bugs. They might uncover that it's not very usable. They are the great usability testing that you can have for free. I mean, you're paying them the salary because they're, hopefully you have a paid interns at least. The exploratory testing is the next example of domain breakers. There is a great book I've read recently called Explore It that I linked in my Twitter as a reference that you can buy by, I believe Elizabeth Hendrickson is an author. It's published under Pragmatic Programmers. It's not a big book, but it's explaining how to deploy and use exploratory testing in your practice. For example, we in my team, what we do is we call them blitzes. After we've finished the feature, we bring up people who haven't worked on that functionality. And we just tell them in general where that functionality is based, how they can use it. We don't give them the task plan. We just tell them, try to play with it and see how it works. That uncovers quite a few bugs. So you have basically real customer tests at hand. Chaos testing, Chaos Monkey from Netflix is a very well-known test automation. Basically, if you have microservices, just randomly drops one and sees if your application is still functioning or not. And last but not least, I sometimes recommend is a fuzzing testing, where you just dump a ton of data, random data, on your production application. So if you were to bring it all together, though, I always say that there is a place for design and tests, not just design and software development, but also in tests. There are people who have a title, test architects, and they do an amazing job. And now in US especially, we are becoming so-called hybrid engineers, where we don't have a titles, tester and developer, we all have the same title. So they have to be bringing the design principles, practices into the testing, while utilizing the test expertise that testers might hopefully have, right? So it's important to accumulate and integrate the two. And ultimately, I always say in this particular presentation is that domain-driven design, there is a place for it in testing in particular. So my call for actions for you guys is that really evaluate your test architecture. The things I've mentioned about ubiquitous language are important. Establishing boundaries is essential. Trying to talk the same language. I've seen over and over in many countries that I go to that there is sometimes hostility between the two camps, testers and engineers. You want to avoid that at all costs. So you want to have the same language, the communication. While still you need to be creating the boundaries. You need to know what's your focus is on. Don't go beyond, if you sales context, don't go to the support context. Focus on your department. If you use a third-party library, you're not going to test the third-party library. You trust them enough that they would continue working. And again, unify your test architecture. Have the strategy, have the communication discussions of the releases and the features you're working on. And experiment. It's very important. If you are going for the next new design, make sure that after you experiment, you show that design. The POCs, the proof of concept of new test frameworks is essential to share that with your team. And try not to create those silos. Have the communication in place. That's essential for team growth and the team progression. So with that, I thank you all for joining me, and we'll go to the Q&A. Thank you so much. Thank you. Any questions? I often asked on the future of domain-driven design, because it's been around for, you can see, for many years, as I've mentioned. It's actually been growing quite a bit. The number of conferences is growing like crazy, especially in Europe. There is a great conference called Domain-Driven Design Europe happening in January. There are many throughout, I believe, in UK. So that's part of the design is really growing and evolving. Usability testing, or people sometimes say UX first design, is also taking a lot from domain-driven design. So I really encourage you to look at that. It's fascinating. I would say Eric Evans is a good start. Van Vernon is very use case oriented, if you like that more. Yep. Great. If you ask yourself a question, it always starts a question, so I always love that.
Yeah. Hello?
Hello.
Not sure, is it? Yeah, it's working. I would like to hear a bit more about the architectural lifetime, because a well-known statement is that the architecture is something hard to change after you applied it. and how feasible is to review your architecture so often if you gather a number of tests and a huge application, if it's let's say for some clever architecture structure, to revise it on the third and the fourth year if probably the lifetime of the application will be a couple more years from now. What do you think?
Great question, great question. So let's take a first one, the fact about the architecture. It was any sort of, especially if you look at JavaScript, for example, or UI frameworks, people tend to say, let's rewrite our whole app in React. Let's rewrite it in Vue, right? The return on investment, you really have to look at it closer. If you use the layered architecture, as you said, it's so difficult to change. So you always have to really look at the the pros and cons evaluation. If you're gonna keep moving towards, if scalability is a problem now, right? You might look at some new architecture type, hexagonal type, right? And say, there is enough benefit that I would invest the resources into and I would refactor the whole application. Sometimes it makes sense. Sometimes it doesn't. Unfortunately, more than not, it doesn't make sense. Legacy systems, the Michael Feather's book on working with legacy systems, he really pushes the point that if it's not broken, don't touch it, don't refactor it, right? So if you have a legacy system, it might make sense to leave it. Some companies like Basecamp, if you've heard of, what they've done is they create a completely separate version of the app that they rewrite in a new architecture type, while still maintaining the first type. They just don't change it. It's a legacy. So rewriting sometimes doesn't worth it necessarily, but slowly refactoring always worth it while you're in the area. And if you see the benefit of refactoring, of building a new architecture outweighs the cons, you just go for it. You create a second version completely, you isolate yourself. That's why I like React so much, because React is known for, you can build your own empire in the middle of any crappy application that you have. You can slowly build out that virtual DOM in your app, even if you want Angular or any other framework in place. So there are ways, but again, never just do it because it's fancy and you have to evaluate the return on investment.
But isn't you talking about more than a refactoring an application instead of reviewing the architecture of the whole application? Because in my opinion,
you have to do both. You have to review it.
Yeah, definitely, because you could not just change your application magically from one to another state. But isn't this serious lifetime architecture involvement driven exactly by the business needs? I mean, if the business have a problem and got money from something, this could be the only serious point for reviewing the architecture application architecture.
I totally understand. It always depends on the situations, but I would say there has to be people who really know the long-term vision and the overall application. So you need to be reviewing that. But it's a challenge with legacy system in particular, because you don't know the behavior sometimes at all. But you should be continuously reviewing. That's what the context map is for. So you know what pieces are connected and what your focus is on. You continuously should be reviewing incrementally, because otherwise you would be, just messing up your application. But you have to be aware of what you're working on. This is what the whole subtitle of know what you're doing. So I would say continuously refactoring, reviewing is the way to go. If you see that it's blocking you, your whole architecture principle, and you can determine and explain to your business owners that it's worth dedicating time to completely rewriting your app, you just do it. But again, you always have to evaluate that. You can't just go for it. But sometimes it's easy to refactor, then just keep growing this horizontal architecture. You go like, not virtual, you go for horizontal, right? Your needs, as you said, business needs, you have to be able to explain to them that the new approach is the way to go. Yeah, let's chat more. But yeah, if you have any questions, my Twitter account I've mentioned, Dmitry Vinnik, or chat with me right after this. I also would love to. Yeah, thank you so much. Yeah, sorry.